So this is the state of our module website, and I want to go into this section today. A couple of topics that I want to cover today now. So there's may look a bit daunting, but there are 3 sets of slides, but this is a very short set. This is quite short as well, and this is kind of medium length. The lab is just a continuation of our movies app. So if you remember from 2 weeks ago, all we have at the moment is just static components. We're going to start adding dynamics to it, which really means adding the use state and use effect hooks to it. And we'll also add something called routing, which is why I need to cover this topic here this week, or begin to cover it anyway. Fairly significant archive this week as well. So the first thing I want to do is actually go back to JavaScript and cover 2 aspects of the language. I'm covering them now because we will see them maybe not in this week's lab, but in next week's lab. So just so that you are okay with the syntax as it appears in the labs. So that's where I'm going to start off. Again, just feel free to butt in if you've got any questions. Don't wait for me to pause or anything like that at any stage. So I'm calling this my ES6 top-up, and the code that I'll show you here now is available in the archive for this week. There's 2 aspects of the language that I want to cover predominantly. That's destructuring and the spread operator. The third one there, I'm not that concerned about because we don't really need to know about it. And these 3 topics really, certainly the first 2, I'm not too sure about the third one, but the first 2 were features that were added to the language in 2015. So they're part of this ES6 upgrade to the language. So what destructuring is this ability to assign properties of either an array or an object. Otherwise, I suppose we should call them elements of the array. But either way, arrays and objects are what we call collection data structures. And if we want to take individual entries within that collection and assign them to local variables, there's a new kind of declarative way of doing that. We could always do it in the language, but we had to do it in an imperative style. But now there is a declarative approach towards doing it. And the declarative approach was added mainly because it's something that we do quite a lot. So I'm just going to jump over now actually to the code. I know I have code samples here, but we'll look at them in VS Code if that's okay. So again, you get the code that I'm going to look at now in this archive here. So it's this folder. So it's destructuring I want to look at first. So I've got a file here called 01 destructuring, and we're not going to bother now with the live server. We're just going to run these from the command line using the node runtime. So it'll be node 01, and it outputs just it console logs just a whole bunch of stuff. So let's look at the code and step our way through. It's all fairly straightforward, really. So without destructuring, I've got this array here, and I want to assign the elements in the array to individual variables, and that's really just what I'm doing here. So that's what I would call an imperative approach towards doing this. But in ES6, we've got a declarative style, and so the declarative style is here. So this is what we refer to as destructuring now. And the way you interpret this line of code is, I want to take the array on the right-hand side and take the first entry in the array and assign it to a new variable called v1, take the second entry and assign it to a new variable called v2, and take the third entry and assign it to a local variable called v3. The square brackets around that collection of variables there indicates that the thing on the right must be an array. That's significant. So if I do a console.log of v1, v2, v3 as I'm doing here, then it should output 10, 11, 12. And if we look down here, that's what we're getting here. So that's simple destructuring going on there. So it's one line of code. It's one line of code versus 3 lines of code. That's what we're gaining. Sometimes we may not be interested in all elements of the array. So what you see here in this line is I'm only interested in the 2nd and 5th entry in the array on the right. And so the comma there is telling the runtime to skip certain elements. And if there were many elements, which there are, if there were many elements after the 5th element, then that doesn't matter. You can see in our case, there's actually a 6th element. So we do not have to put a comma kind of in here just so it matches up. It'll just ignore the rest of it. And the comma at the beginning here means skip the first element in the array, take the 2nd element and assign it to a new variable called v2. So when I do a console.log here, I should expect to get 11 and 14. And that's what I get here. Sorry, that's what I get here. Similarly here, same kind of thing. I'm interested in the 1st element, the 3rd and the 4th, so you don't have to assign values. You don't have to declare variables for everything in your collection on the right. That's destructuring applied to arrays. We can do the same with objects. So without destructuring, this is what I would have to do. Here I've got an object with 2 key value pairs. And this is kind of an imperative approach where I'm declaring local variables called alpha and beta. I don't have to call them alpha and beta, but they just happen to match up the key in the array. So we know how to interpret this piece of code. If I want to do that in a destructuring way, this is how I do it. This line here. Sorry, this line here. So it's curly braces now in this case, and the curly braces tells me that the thing on the right is an object rather than an array. And so what happens at runtime is the runtime takes that variable name alpha and it looks for the matching key in the object, and there is a key called alpha, and it assigns to this local variable, which it declares whatever is assigned to the alpha key, which is 100. Similarly for beta, it's going to declare a local variable called beta and assign it the string enterprise. So the console.log here corresponds to what we get here. Again, so it's one line of code. It's one line of code here versus 2 lines of code here. Here's another example. In this case here, we're kind of restricted to calling our local variables alpha and beta. Maybe we want to call them something else. And that's what's going on here. So here I'm saying I want to declare a new variable called num. And I want to assign to that variable the value associated with this string in this object. So num is going to have a value of 100. Similarly here, I'm going to declare a local variable called word, and it's going to be assigned the string enterprise. And that's what we get when we console.log. That's what we get here. Obviously, the order is important in arrays, but it has no significance in an object. There's no such thing as the first key value pair, the second key value pair. So here again, in this case, I've got 3 key value pairs. Foo happens to be the last one, but here in my destructuring, I'm referring to foo at the beginning, but that doesn't really matter. Okay. And so similarly down here, it looks like here, all I'm interested in is extracting the foo part of my object. So this is going to declare a local variable called foo and assign it bar. And if you wanted to rename it to something else, then you would just go All right, you just go foo : foo : whatever you want to call it. Okay, so that's destructuring, which you will see quite a lot. That's the first aspect of JavaScript that came in ES6. Going back to our slides, we have this spread operator was introduced as well, which is this triple dot operator. Sorry, just 1 second now. This spread operator, which is the triple dot operator. In JavaScript, we refer to arrays and objects as iterable structures. I'm sure that's a term you've heard in other languages. And what the spread operator allows us to do, we apply the spread operator to an iterable structure. And what it does is, and kind of the clue is in the name, it takes the individual elements of that iterable and it spreads them out into individual elements. And typically we would do that where we would expect to usually have 0 or more arguments in an expression. So by taking our iterable, prefix it with the spread operator, it actually spreads out the individual entries in that iterable, where normally the expression is expecting a number of elements. So I guess examples is really what would clarify this. So going back to my samples, and I have a 0.2 file with a number of illustrations of this spread operator. It's used in a number of different contexts. The first context is not one that we are terribly interested in, but I'll just show it to you anyway. So I've just got a function here that expects 3 arguments. And the function doesn't do anything interesting. It just outputs one of them. So if I've got an array here, which happens to have 3 entries, I can call, when I call my function, so the function expects 3 things passed to it. But if I take my array and prefix it with the spread operator, then it's going to spread out the entries in the array into 3 separate things. And that's what my function expects. It expects to be passed 3 arguments. So x is going to be assigned the value 0, y the value 1, and z the value 2. So you may see that being used sometimes. I don't think I ever use it in my code, but and so if I run it, scroll back up. So y equals to 1. That's coming from the fact that 1 is going to be assigned to the variable, to the argument y in my function. Okay, so x will be assigned 0, y will be assigned 1, z will be assigned 2. So that's one usage of the spread operator. Here's another example of where we use it. So I've got this array with some words in it, and I've got another array with some words, and I'm taking the first array and I'm prefixing it with the spread operator. So what's going to happen at runtime is the entries in this array that I've highlighted are going to be spread and mixed into the outer or containing array. And we can see that here. Okay, so shoulders, what is it? Shoulders and knees are just appearing here as kind of ordinary entries in the outer array, the containing array. You know, if I didn't use the spread operator there, so if I take that out, save that and run it again, now what happens is, you know, the second entry in my outer array, the second entry is just an inner array. And that's fine if that's what you want, but let's suppose in our case, we wanted what we had previously. So the spread operator had that effect of just taking the smaller array and spreading its individual entries into the outer array, because that's what we wanted to achieve, I guess. So that's the spread operator. That's two use cases for it. Moving on down to our example code. The next example is here. So I've kind of got an array. What am I doing here now? Console.log. I think am I doing the same thing? I think I'm probably doing the same thing, really. I've got this, well, yeah, I'm contrasting this versus this, which is really what I've kind of already illustrated to you. So I'll just move on from that one. In this example, this is kind of the third use case. You can use the spread operator if you want to make a copy of an array. So I've got an array here. Now, this assignment statement, as you know, that doesn't really create a copy of the array. All that we're doing here is we're declaring a second variable called R2, and it's pointing at the exact same array that R1 is pointing at. So we don't have a copy there. We've just got two variables pointing at the same thing. So if I do this, if I add something to R2, and then if I do a console.log of R1, then R1 is going to reflect the fact that I've just added a D to the end of my array. So there's only a single array there. Whereas here, what actually happens here is it creates a completely new copy of the array. So I'm taking R1, spreading out its individual elements and putting that into a new array. And so R2 is pointing at a completely new array, and I'm proving that to myself by pushing something onto R2, pushing the letter E. But if I do a console.log of R1, it will not have the E in it. It'll just have A, B, C, D. And the console.log down here kind of confirms that if you follow it yourself. You can go back over this yourselves. So that's a third kind of use case for the spread operator when we want to make a physical copy of our array data structure. Same applies to objects, as it turns out. In this example, okay, this is where are we now? Fourth use case, not one I see that often, but if you've got a string and you want to create an array consisting of the individual letters in the string, then that's really what I'm doing here. So here I'm prefixing the spread operator and prefixing it on a string. So a string is technically an iterable as well. In my slides, I said only objects and arrays are iterables, but a string is as well. So the letters is now going to be a completely new array with HELLO as individual single character entries in it. And again, you can see that down further here. Where are we? We are here. Applying this to objects. So we've got this object here, which contains some of my details. And I've got this other object where I've got some other of my details, but I'm inserting the first object into the outer object. Now, the way I've inserted it here, because I'm not using the spread operator, what will happen as a result of that is what you see here, right? It just creates a new key called part of me, and it assigns to that key an object. So it doesn't really spread. What I really want, I think, is to spread the individual key value pairs in the smaller of the two objects, spread them out inside the larger object. In other words, what I really want is this effect here. And the way I do that is to use my spread operator as I'm doing here. So in this case, it takes the key value pairs in this object and it spreads them out into the larger object. Here's another example. This is a technique that can be useful if you've got an object. So here I've got the me object with various key value pairs. And what I want to do is update one or some of the key value pairs. I want to update them, and I also want to create a completely new copy in that update. I don't want to update the original one. So I want it to be immutable, if you like. I want my me to be immutable. So what this line here does is it creates a new object. It takes the key value pairs in the me object, spreads them out, and then it adds this additional key value pair to my my new object. But of course, the address key here is already in the me object. So the net effect of this is to essentially overwrite the value of address inside in me, overwrite it with a new value, which is effectively kind of an update. It's a copy and update, if you like. So when I do the console.log of update me or updated me, then if I just push this up a little bit, it now has address here at 2 High Street, whereas the address was 1 Main Street in the original me object. So as I said, that's a technique that we often use. Next example. So far, we have used the spread operator on the right-hand side of an assignment statement. And it does what I've been telling you it does. If you use the spread operator on the left-hand side of an assignment statement, it kind of has the opposite effect. It has the effect of gathering things together into a single collection. And so that's what's going on here. So I've got the me object again. So I've got the me object again here. And I'm taking the me object and I want to create a completely, what I'm doing here is essentially destructuring, I'm combining destructuring and the spread operator. So what happens here is I want to create a local variable called address. This is just the destructuring part of it. Create a local variable called address and assign it the value associated with the address key in my me object. So it's going to be assigned, this. What happens here is it's going to create a local variable called rest, and it's going to take all of the other key value pairs in the me object and assign it to that rest variable. So it essentially gathers all of the remaining key value pairs in the me object except this one and puts them into a new variable called rest. As in, it takes the rest of the key value pairs in the me object and puts it into a new local variable. You don't have to call it rest. It seems to be a convention that we do. So when I do a console.log of rest here, I would expect it to have all of the key value pairs except the address key value pair. And if I scroll on down, that's what we're essentially getting here. If you check it yourself later on. So that's the spread operator being used, and a number of different use cases for it. And again, it's all about expressing our code in a more declarative way rather than using it in, rather than writing imperative code, which means physically less code to write. The final aspect of JavaScript, which I'm not too really interested in, is this notion of default arguments to functions. So I've got a function here, and really what we're saying is if x1 is not assigned an explicit value when the function is invoked, then by default give it a value of 1. And if the y argument is not given an explicit value in an invocation of the function, then give it a default value of 2. So if we take this example here, I'm calling my function and I'm only passing it one argument, 5. So it works from left to right. So 5 is going to be assigned to x, whereas y is going to default to 2. So when I do my addition and return the result, I'd expect to get back 7. And here, I'm not specifying anything for x, and I'm specifying 1 for y. So x is going to get a default value of 1, and y will get 1 as I'm explicitly saying it. And in the third example, I'm not specifying anything for x or y. So they're going to get the 1 and 2 default values. And so if we look at the console.logs, that will kind of confirm that for me, hopefully. I think they are right. And again, you can check that yourself. As I said, I don't use that much or at all, I think, in the code, but I certainly use destructuring and the spread operator a lot. And you will see it used a lot in any code that you read associated with blogs or articles. That's that. I'm going to go on to this section next because it's the shorter of the two. So this is looking at the whole area of design, which I haven't spoken about at all so far. So let's see what I have to tell you in relation to that. Now, when we, sorry, now again. Just stuff keeps popping up on my screen that kind of get in the way. So when we talk about design, there is design at the component level and design at the app level. Here, I'm dealing with design at the component level. I will release a pre-recorded lecture which explains how we should approach design at the app level. You know, you might remember I've mentioned to you maybe once or twice now in earlier lectures where I've shown you component hierarchy for an app, and some components are stateful and some are stateless. And I've said to you a number of times, don't worry about how I came up with that design. I'll explain how you come up with it later on. Well, I will explain the process that you go through for designing the component hierarchy for an app in a subsequent lecture, which I have pre-recorded, and I will release it later on this week. I think it's about time for you now. You would be able to make sense of it. In this set of slides here, I want to deal with design at the individual component level and just talk about one or two aspects of component design. The title is Design Patterns, and design patterns is a software engineering topic in its own right. It's not unique by any means to React development or single page app development or web development. It's software development in general. And the book cover that you see on the left there is a kind of a similar text in this whole area. And this book now was published back in the mid-90s. So it's quite an old text, but it's still highly regarded. And so design patterns is a topic that has been around for a long while, but it only emerged really a number of decades after software development was a topic. And so the idea behind design patterns is, I'm telling you there at the bottom of the screen what a design pattern is, a kind of definition of it. And what it is it's generalized, repeatable solutions to commonly occurring problems in software engineering. You know, if you think about it, there's been a heck of a lot of software developed over the decades. And for sure, applications have their own unique aspects to them, but there are recurring aspects of software applications across the board. So should software engineers really be required or expected to come up with their own unique design for those parts of their applications that really are common across many other applications? And the answer, I guess, is arguably no. More than likely, there is a recognized good approach towards designing or structuring the code for those particular parts of an application that are fairly commonly reoccurring. And this textbook, the design patterns textbook, the authors of it, what they really did was they surveyed a large collection of software application implementations, more than likely open source applications that they could get their hands on, looked at the design from a modularity and component in the general sense now, module I suppose might be a better term, the design of individual modules or individual sub parts of applications, looked at the designs and abstracted from them what they considered to be the best design approaches towards particular types of problems. And they documented those generic design approaches in this textbook, and it has become widely read and widely applied. So that's where design patterns kind of comes from. These generalized, repeatable because lots of software engineers find themselves trying to implement a particular feature in an application that somebody else has already implemented in another unrelated application. So they're generalized, repeatable solutions, i.e. design solutions to commonly occurring problems in software engineering. When we talk about design, reusability and separation of concerns are objectives that any software engineer would have when they are developing code. And I'm sure you've heard of both of these terms before. Obviously, they are desirable. We'd like the individual modules in our applications, or some of them anyway, to be reusable within an application or reusable across applications. Similarly, each module, and I'm using the term module here in a very general sense, in the context of the React, I suppose a module would be a component, but we would like each module or unit to have a single concern or a single purpose. And so each module or unit or component, their concerns should be separate from all other units within an application. And that all kind of leads to having applications that are more maintainable, easier to understand for other people when they're looking at your application design. Now, linked to reusability and separation of concerns is this DRY principle, don't repeat yourself. Obviously, when you look at all of the code within an application, there shouldn't be repeating code occurring in different parts of your application. If it does, then you need to refactor that code and put that repeating code into a single unit or component or module, therefore making it reusable. And also that module now has its own kind of separate concern in the context of the overall application. So these are all just general design principles. And again, I'm sure you've heard of all of these prior to this. Linked to the dry principle, like how do we approach trying to achieve dry units within our code base? And arguably there are kind of two approaches. We could take an inheritance approach or a composition approach. If you've done any object-oriented software development, like using Java or C++, you certainly will be familiar with inheritance, and I'm assuming people are. Essentially, or a simple way of kind of explaining inheritance is what you're looking for in your code base is what are referred to as is-a type relationships. You look, sorry, not in your code base, but in your problem domain, you're looking for is-a type relationships as you're kind of modeling your problem domain. So an example of an is-a type relationship might be here. A car is an automobile. So if I was developing an application where car was a concept in my problem domain, then more than likely, and I might have other types of automobiles as well, then more than likely, if I was using Java, I would have a automobile class, and subordinate to that, I would have a car class. So, and anything that's common to car and other types of automobiles, the common code would be put into my automobile class, all of that good stuff. The alternative to inheritance approach is what's referred to as a composition approach towards software development. And in composition, you're looking for has-a type relationships. And an example here is a car has an engine. So when in a composition approach, I might have a car class, and within that, it has a property, and the property within that class is a property of type engine. So I'm kind of composing things together. I might have another class called, I don't know, aeroplane. An aeroplane would have an engine property as well. So I'm not using inheritance in this case, I'm using composition instead. Now, you're all very familiar with inheritance. I'm pretty sure you may not be, I'm sure you may have heard of composition, but you may not have approached software development or design, software design in that way. It turns out that React is more geared towards composition rather than inheritance. Now, going back to patterns, because they're all kind of interrelated. Over the years, in the context of React anyway, design patterns have emerged, and these design patterns are based on this composition modeling style as opposed to inheritance. And I'm just mentioning the three most common patterns there in the list. We are going to look at the first two. Now, React has been around since what, 2012, 2013. And in 2019, this whole kind of hooks technique was introduced into the programming model, and we started looking at hooks last week. Kind of turns out that hooks have reduced the importance of some of these design patterns that I've listed here. In particular, they've kind of reduced the need to use higher order components as a pattern, and maybe even render props as well as a pattern. We will use render props, as it turns out, in our movies app. We could have used higher order components, but we don't need to, because hooks kind of take care of it for us. The container pattern, that's still relevant. Okay, so hooks has kind of changed the landscape for us a little bit in relation to design patterns. But it still, hooks is still kind of geared towards this reusability, separation of concerns, objectives, the dry principle. So they've actually helped us to achieve those objectives. Before I talk about, so I just want to talk about the container pattern today, and I'll talk about the render props next week. I won't talk about higher order components at all, actually, but you may come across it if you read around this topic. Before I talk about the composition pattern in relation to React, composition is really part of how HTML works, because that's really all we do with HTML. We compose different HTML tags with other tags. So on the left there, I've got a div tag, and on the right, I've got a div tag as well. But on the left, I'm composing the div with a H2 and a UL element, whereas on the right, I'm composing the div with a paragraph and an image and an anchor tag. Also, in the language of composition, and the language of HTML, we talk about children. So I would say that H2 and the UL elements or tags are children of the div tag. Over here, paragraph and the image and the anchor tag, they are children of the div tag here. Similarly, the LI elements here are children of the UL element. So that notion of composition and children, those two terms kind of are important in the context of HTML, and they're also relevant in the context of React. So back to the container pattern in a React context. And so I'm saying all React components, by default, they have a children prop. We haven't seen it so far, but we'll see it from this week on in our lab, and we're mainly in the lab. So by default, a React component has a children prop. And I'm saying that the children prop, what it essentially allows us to do is it allows one component to pass components to another component. So the component that's doing the passing, we refer to as the consumer, and the component that's receiving the components, it uses the components that it receives to determine what it should render onto the screen. So if you like, the consumer is dictating what the other component should render because it actually passes some components to it. So we've components being used at 3 levels, kind of, if you like. An example hopefully will clarify it. So I've got a component here called picture, and I would refer to this now as a shareable component, which is kind of the whole idea, sharing and reusability. That's really what we're really trying to get at here. But I've got this picture component, and I've kept it very simple, right? So it renders an image onto the screen, and it's given the image URL, let's say, as a prop. But it also renders a children component, which is actually passed to it as a prop as well. Okay, so that's that. On the right, then, I have what I'm calling my consumer component, and the consumer is using the picture component on the left. So here's my consumer, has some logic in it, which we don't care about. And here we go, it's using the picture component. And I have my open picture tag and my close picture tag. And any JSX that I put in here, it's that JSX is going to be bound to the children prop that's passed to my picture components. So whatever JSX I put in here, that is going to be rendered here as part of my picture. Hence, the consumer is dictating what the picture component should render, as well as the picture component rendering an image as well. So the picture component renders A, an image, and B, it renders the what the consumer binds to the props.children prop, okay, which would be some JSX. And to take that further, and so what we're actually achieving here is we're kind of decoupling the picture component from its contents, and the contents that the content that the picture component renders onto the screen, or some of it anyway, is actually controlled by the consumer. Hence, our picture is reusable. So I might use my picture component like this. Okay, so here's one consumer, and it's using the picture component, and it's passing a button as the children prop. So the picture component would render the image followed by a button. Here's another consumer that's using the picture component, but it wants an unordered list rendered after the image. And so we would get this. Here's another one. And there's some sort of complex component being passed down as the child. And so my picture renders an image, and whatever the complex component is renders. Hence, we've got reusability of our picture component, which is one of our objectives from a design point of view. Another way of saying it is that we are composing the picture component with other elements, I suppose. So the picture is composed with other elements or other components. And that's essentially the container pattern. Pretty simple, used a lot throughout our React implementations. Okay, so I'm going to park that in the context of design patterns, and I'll come back and look at the other one next week. And the reason I'm breaking it up this way is because I'm covering topics as I need them for the lab. That's kind of my rationale here. That's why I don't continue on now and look at the rest of the design pattern, because if I do that, then I can't cover the next topic that I want to look at, which is routing, because we actually use routing in the lab as well this week and in subsequent weeks. So I'm going to park that for now and move on to another topic. I know I'm jumping around now, but so now I want to talk about navigation or routing. How do we add navigation to a React app? And for this set of slides, the archive contains some sample code as well. I'm not going to cover all of the routing samples this week. I'm going to cover the rest of them next week. So next week's lab, there'll be more routing stuff and there'll be more design pattern stuff. That's the way I'm approaching this, which hopefully will make sense to you eventually. So let's see what's behind this set of slides here. So routing is the ability to add navigation, because navigation really is a core part of the web. We like clicking on links and going to different pages. And as we click on a link, the URL in the browser changes and what we see on the screen changes. That's the way the static web works. We'd like that same experience in our apps, in our browser-based apps. Turns out now that React framework doesn't support navigation at all. And this goes way back to the very first lecture that I gave you on React. And we talked about the model view controller pattern, amongst other things. We said that React only focused on the V part of MVC. And this is coming home to roost now, because React doesn't actually support navigation at all. We need a separate library to do that. There are a number of them. By far and away, the most popular one is a library called the React Router library. But that library is maintained by a completely separate team from the React team. And it's not it's not part of the Facebook organization or anything like that. So what is the whole point of navigation or routing? Terms are interchangeable. And what routing will allow us to do is have multiple views or pages in our app. Now, React is classified as a single page app framework, and we can now actually make sense of where that term comes from. If you look at the code base for our for any React app, and we're more familiar with the Movies app, then if you look down through the code base, there will only be one physical HTML file, which is called index.html. And if you look inside that file, it's really just a shell. So we only have a single page in our React app. But what we'll see after this week's lab is we have the experience of the sense that there are multiple pages, because we will be clicking on hyperlinks and the entire content of the screen is going to change. And as the content of the screen changes, the URL address in the browser changes. So we have this impression that we are moving from page to page. But there is only a single HTML page in our code base, hence the term single page application. There is only a single HTML page, but it's an app in the sense that it has multiple views associated with it. So that's where the term single page app comes from. And it's important, it's really important that as we click on links, not only does what this is displayed on the screen changes, but the URL in the browser changes as well, and they stay in sync. And that's a core principle of the web. It's this addressability principle, which I've mentioned before. This idea that each page or view, we can use these terms interchangeably, each of them has their own unique address, and the advantages of that is if I want you to go to a particular page within my app, you don't have to first go to the home page and then click on a series of links to get to the page that I want you to get to. I can just give you the full URL of the specific page, and by entering that into the browser, it will go straight to that page or that view within my React app. And that's this whole concept of addressability or information sharing or deep linking. They're all kind of interrelated, these three terms. And down here I'm saying that, you know, browser-based apps have been around for a long while, and they predate single-page app frameworks by a number of years, really. But the very first generation of browser-based apps did not support addressability. You had this notion of multiple views or multiple pages, okay, but the URL address in the browser never changed as you moved from view to view. Single page app frameworks brought in this addressability characteristic to our browser-based apps. Okay, so how do we actually implement navigation and routing in React? And so there's a whole series of samples that I'm going to need to work my way through. And as I said, I'll only work through some of them today. And the way these samples work, if I just bring them into my VS Code. So this app was created with the Create React App tool because that was the most convenient, really. But as you can see in the source folder, I've got a whole series of samples, subfolders, and they're meant to be separate little mini apps in their own right. They're kind of independent of each other, although they do share some components, all right. And so we'll work our way through the samples, and the way you can see what a sample or how a sample works and what it displays in the browser is you go to the top level index.js file, which is this one here. And it only has one line of code, an import statement. So if I want to see how does sample one work, then I import sample one. If I want to see how sample two works, I change it to 2, save it, and then having saved it, you know, the Create React App development server will do its thing, and so on. So that's how we work our way through the samples. So let's start with sample 1. Go back to my slides. So what we need to do is we need to write some routing configuration. And let's supposing this is our objective here. I want my app to have 3 pages or 3 views. I want these to be the URLs associated with the 3 views. And I want these to be the top level components associated with each view or each page. So the home component, it may have a number of child components, but this is at the top of the hierarchy. The about component, it may have children. In our case, they don't really, but they may in general. So if you like, these are my three top level components, or these are my three pages, and these are the URLs that I want to have associated with them. So how do I express that objective in my React code? And so this is how we do it. And we actually express it using JSX syntax, which is nice. So the React router library, which is the library that we're using here now, it's very much aligned with the React framework itself and how it does things. And so, you know, okay, this is the first time you've seen maybe this routing configuration code, but you could nearly make sense of it, in particular if you focus in on this part here. So I've got 3 route entries, which corresponds to my table on the left. And so the first route entry is saying, if the URL in the browser is that /about, then mount the about component at the top of my component hierarchy. And if there is a component, which there will be currently at the top of the hierarchy, then that will be unmounted and all of its children will be unmounted. So the about component is mounted, and once you change the component, once you make any changes to the component hierarchy, that's going to impact on your virtual DOM. Your virtual DOM is going to impact on your real DOM. And once the real DOM changes, then the browser repaints the screen. So all of that is going on in the background. Similarly here, this route entry is saying, if the browser's URL changes to this, then unmount what's currently at the top of the hierarchy and instead mount this at the top of the hierarchy. So I'm expressing my routing configuration here. And this is a kind of a default one down here. This is saying if the browser's URL is none of the above, then by default, force the browser's URL to be this. And the slash on its own matches my third entry here. So it always goes back to the home page, if you like. Now, all of this code is put into a component, which I've called app. You call it anything you want to. And it's actually the app component. It's this component that contains the routing configuration. That's the one that you pass to the React DOM.render. So technically speaking, this app component here, it is always at the top of my component hierarchy. Immediately below it are this one, and then below that again is one of these, if you like. But the browser, the app component doesn't contribute anything to what's displayed on the screen. The browser router component doesn't. I'll explain in a minute what the purpose of the browser router component is, but it doesn't contribute anything to what the user sees on the screen, neither does switch. So it's only these here that contribute to the virtual DOM. So technically, these components are not at the top of my hierarchy. Technically, this is at the top of my hierarchy. This is subordinate to it. This is subordinate to that. And then my custom components come into play. But, that's a very long-winded explanation. My guess is that once you see this, you'd have kind of worked out what I'm trying to express here. And what I'm trying to express here is what's appearing on the table on the left. So this is, we would say, it's a declarative way of expressing my my routing, the routing behavior or the navigation behavior that I want. So the browser router, what it does is essentially tries to match the browser's URL. So whenever the browser's URL changes, this browser router component kicks in straight away. Sorry, just to rewind a little bit. When the browser's URL changes, that's effectively a browser event. And when that event occurs, this browser router component handles that event. And what it does is it takes the string that's in the browser's URL address bar and it tries to find a match with one of these here. And the first match that it finds, then that's the one that it applies, as in it mounts the corresponding component and unmounts the one in its place. So it has a very important role in terms of reacting to the browser's URL address changing. And that might change as a result of the user physically typing into the address, or more than likely as a result of the user clicking on a hyperlink. And we'll see how the program hyperlinks in a moment. When a hyperlink is clicked, then the browser's URL changes, and then the browser router component steps in and deals with that event and makes a decision accordingly. The root components within this suite of components that the React Router library provides. The root component, as we can see up here, it takes props, and the path prop contains a string. Now, you can have wildcard characters in that string, so there's a certain amount of pattern matching that it will support. I don't think I use it at all, actually, but it can be supported. Which is what I'm saying there. The redirect I've already mentioned, it takes care of that 404 problem. What the switch component does is it only allows for one of these routes to match, which is really what you would want in most cases. And React on that render, I've mentioned that. So to an extent, some of this is boilerplate, and all that changes from app to app is the route entries that you have here. The order in which you put these can be significant. So I might come back to that at another stage and show you an example of where if you order them incorrectly, then you don't get the behavior that you expect. Because essentially, this is a switch statement, just as like a switch statement in normal programming. So once it finds the first match in this set, then that's the one that it uses, even though there might be a match further down the list that you would have preferred it to use for a particular use case or for a particular scenario. But the order isn't relevant so far to us anyway. And so sample one, if we have a look at that. So my sample one, I've kind of packed everything into one index.html, sorry, into one JS file. And if I scroll down to the bottom of it, here's my routing configuration, which we've looked at. And the various components about, home, and inbox, they're just simple little components that I've coded here. Nothing too interesting. But just to see it in action, we need to go to our index.js at the very top, make sure it's pointing at sample one. Save that. Start up my development server. This is a create React app now, if you like, even though I'm kind of abusing and putting multiple apps into the one create React app project, but yeah, that's okay for the purpose of illustration. Okay, so forgetting about the domain part of the URL, localhost 3000. The only part, the URL that needs to be matched is just the slash on its own. And we saw from the routing configuration that matches the home component, if you like, and the home component is just rendering that onto the screen. If I go on to, if I physically change this to /about, then the React Router library responds and finds the match for me. Okay, and similarly for inbox if I wanted to. That's the kind of 101. of having navigation or multiple views within my app. In my case, I have 3 different views. And if I do, if I put in something that doesn't match, then my redirect kicks in and it sends me back to the home page. Next is hyperlinks, and there is a separate component provided by the React Router library to implement hyperlinks called the link component. So the idea is that if you want to have hyperlinks within your React app and the hyperlinks take you to other parts internally within the app, then you should use the link component as opposed to the HTML anchor component. If you want to have hyperlinks within your React app that sends the browser to a completely different app or a different web page outside of the React app, then from an intent point of view, I guess you should use the anchor tag, but they're kind of interchangeable in many cases. But by convention, we use the link component rather than the anchor tag to implement hyperlinks that we want to cause redirection when we want to cause redirection within our React app. Because as it turns out later on, we'll see that the link component allows us to do extra things like pass additional props to the component that we want to have mounted, and we can't really express that using the HTML anchor tag. So that brings us to sample 2, and I just have a screenshot of sample 2. So I've got 2 hyperlinks in my home page, and no guesses for what's going to happen. If I click on the inbox hyperlink, it's going to take me to the inbox page. If I click on the about hyperlink, it takes me to the about page. The notion here now is this little app is a very, very, very primitive kind of email client, hence inbox. But if we looked at the code behind this hyperlink here, this is what it would look like. So here's my link component being used. And the link component takes a prop called the top prop, and we send it a string. And so when the user clicks this hyperlink, what the link component will do is it will change the browser's URL to whatever this string is. And as I mentioned a few moments ago, whenever the browser's URL changes, then the routing configuration kicks in and it looks for a match. And the rest we know about. So that's that. Also, you're advised to use absolute path names in your top prop. If you start using relative ones, then you could really get tied up in knots. So always use absolute path names. So the link changes the browser's URL, as I said, which is the event in a browser context that causes my router to kick in and deal with that event, and it goes looking for matches. So I've already expressed that. So just let's look at it, I suppose, to get it running first. It's not too exciting, I know, but we go to our base index.js and change it to the sample 2, save it. Just before I do that, it's probably a good idea. Okay, we're already on the home page. Save that. And these are our hyperlinks. So this takes me to where now the hyperlinks disappear, which isn't great. We'll see how we can solve that in a moment. We'd like these hyperlinks to remain constant across all pages, and we'll see how to do that in a few samples down the line. But this is how the hyperlinks work now. And sample 2, really, in terms of the code, if we go into sample 2, again, everything is stuffed into one index.js. Scroll down to my routing configuration, which hasn't changed. And the home page is where my hyperlinks are. So here we have them, as I've illustrated on the PowerPoint slides. So that's hyperlinks using the React Router link component, which I'm importing here, as well as all the other ones. Next is this notion of dynamic segments. This is a term that React Router library uses, which isn't very, not sure why they use this term. What they're really talking about is what's more commonly referred to as parameterized URLs. The URLs that we've seen so far in our two simple little examples are purely static URLs. A parameterized URL is where part of the URL contains essentially kind of a variable value. And how do we express in our routing configuration that a particular part of a route's path is a variable part? Number one, how do we express that in the syntax? And number two, presumably that variable value within the URL, we'd like to make that available to the component that's mounted as a result of the navigation or the React Router making its routing decision. So here's kind of simple examples of what I might mean by parameterized URLs. So whatever the context of this application is, presumably the 22 here is probably maybe a user ID of some sort. And here as well, maybe the 12 is a, let's assume it's a user's ID value. So the two questions are, how do we declare a parameterized URL in the path of a in our routing configuration? And the second question is, how does the mounted component access the parameter value? Because presumably the mounted component needs to use that parameter value to, I don't know, maybe retrieve data from some backend database, as in retrieve user 22's profile, or in this case, receive all the purchases made by user number 12. So in terms of the first question, how do we express it in the routing configuration? Using our make-believe email client, continuing with that, let's supposing in the inbox part of it, we want to add a parameterized URL. And so this is what we want the URL to look like. We want to have the inbox number after the inbox static part in the URL. So the 123 in this case is the variable part, and it reflects the user's ID, inbox ID. And so this is how we express it in our routing configuration. So the colon here is significant. The colon is telling the React Router library that this part here is a variable part, or it's a parameter within our overall URL. And that's number one. And number two, what the React Router library will do is it will essentially declare a variable called this, and it will assign to that variable the actual value that appears in the browser's URL address. So in the case of up here, it'll assign it the value 123. So that's how we express a parameterized URL in our routing configuration. And the second thing then is, how does the component that's mounted, which in our case is the inbox component, how does that actually access the user ID value that appears on the browser's URL address bar? And not surprisingly, it is actually passed as a prop, but we don't need to access it directly as a prop. So there's a special hook made available by the React Router library, and it's the use params hook. And so you can see me here in the code, I'm calling the user params hook. It doesn't take any argument. What the user params hook does is it returns, sorry, let me just check now. Oh yeah, okay. It returns the parameter value from the browser's URL address. And so you can see here, I'm assigning whatever hook returns to this variable here. This hook now only returns one thing. We saw in the case of the use state hook, it returned a tuple. Well, user params doesn't. It just returns a single value, if you like. There's no sense of having a setter method because we don't want to be able to set the parameter value from within a component. And I'm just doing a console.log of it just as confirmation, I suppose. Down here, oh yeah, I was just thinking that. So params is an object, sorry. Params is an object, and here I'm just using destructuring. So I'm picking out the user ID part within that object. Where did the user ID come from? That came from the fact that that's the name that I gave. That's the name that I gave the parameter in my routing configuration. So I'm just doing destructuring there. So params here is an object, and I'm just doing destructuring on it. And the object only has one key value pair because there is only one parameter in my URL path, my URL string, if you like. I could have multiple parameters or multiple variables, in which case params would have multiple key value pairs, and I would extract them using destructuring in the normal way. And all I'm doing with the user ID value is I'm just outputting it back to the screen as in here. So that's sample 3. And if I quickly look at sample 3, so same trick as before, change that. Probably a good idea always to go back to your home page, which I am. Save it. So just to illustrate it, I've just got 2 hyperlinks here. If I click on this hyperlink, it's going to change the browser's URL to /inbox/ let me just see, /inbox/ 1234. Here's my inbox page, and just to prove it to myself, the component that's actually mounted is accessing the right value, and it's echoing it back onto the screen. Whereas if I take the second hyperlink on the home page, if you like, that changes the browser's URL to /inbox/4321, and I'm picking up the 4321 here. So that's kind of confirming to myself that the mounted component is accessing the parameter value correctly by using that use params hook provided by the React Router library. I don't think they're in the slides. I've shown you the key parts of the code, but let me just quickly look at it. So the index.js, nothing interesting there really. It just has the hyperlinks in the home page. Now, for no particular reason, I implemented the hyperlinks using the anchor tag. Did I implement both of them? Oh no, I implemented the other one using the link tag. So they both work in this case. I suppose from a coding properness point of view, I should probably have used the link tag for both of them because they are hyperlinks to something internal within the application. So that kind of breaks the guideline that I mentioned earlier on, but they both work anyway. And the other components then aren't really interesting, except for the inbox component. And I've shown you the key parts. Well, I've shown you the entire code for the inbox component. This use params hook. This was only introduced in the React Router library in one of its most recent versions, version 4, I think. All of the earlier versions, you had to access the parameter value directly yourself by taking them off of the props object passed into your inbox component. And in fact, it also used the higher order component pattern that I mentioned earlier on. So it's much cleaner now with this special hook that the library provides us with. Admittedly, it's cleaner from a coding point of view, It's a little bit more obscure from your point of view as to how it actually, how the use params hook works, but we don't need to know how it works. What we really need to know is what it does for us. So that's this notion of parameterized URLs. Okay, that's how they work from a mechanics point of view. How you decide which URLs within your apps should be parameterized and which ones shouldn't. In most cases, it's fairly obvious, but arguably, I suppose it's part of the overall design associated with your app. So when we talk about designing React apps, not only are we talking about the UI part of your React app, we're also talking about the different views and what URLs you want to associate it with those views, and which of those views should have static URLs and which of them should be parameterized. They're all part of the design process. But as I said, I think in most cases, it's fairly obvious when a URL should be parameterized. And you will see it from this week's lab. You'll see an example of a parameterized URL, and you'll see others further down the line. So hopefully just by examples, you'll get the general idea as to when you should use parameterized URLs versus static ones. That's this notion of dynamic segments. Moving on to our samples. I think I've covered that. Yeah, I've already mentioned, you can have any number of parameters within a URL, and the use params will just take care of packing this object here with the key value pairs accordingly. So it works with the routing configuration behind the scenes for you. Now, nested routes. So the routing configuration that we've seen, we have put that routing configuration, if you like, at the very top component in our hierarchy. But you can have routing logic buried within your own custom components. And so if we do that, we refer to those routes as nested routes. So my objective is I want components, and this is when you would use nested routes, when a component's child is dynamically determined from the browser's URL. Now, to illustrate this, I'm going to stick with our little email client, our glorified email client. And let's supposing we want some nested routes linked to the inbox part of my application. So what we know so far is if the URL in the browser is of this form here, then I want my inbox component to be mounted onto the DOM. But in addition, supposing the URL in the browser changes to this. So the beginning of it is the same as up here, but I've got an extra little bit at the end, /statistics. And when the URL has all of that in it, then I want the inbox component to be mounted, and I want another component, which I'm calling my stats component, to be mounted as well. And the stats component would be subordinate to the inbox. It would be a child of it. That's one. And the second case is if the suffix in my inbox URL is /draft, then I want the draft component to be the child of inbox. So it's one or the other. Hence, the child of my inbox is determined from the URL in the browser. So where do I express this additional nested routing logic, nested within the whole inbox kind of section, if you like? And I would put the routing logic actually inside the inbox component itself. As in, what we see here. So here's my inbox component. It has ordinary JSX, if you like, but here we can see we've mixed in route entries into our JSX, and they're expressing what I've been talking about there a moment ago. They're saying, look, if the URL follows this structure here, then mount the stats component mounted at this point within this overall inbox component. And similarly for the second route entry. Again, play safe and use absolute path names. So that's nested routes. We don't use them, as it turns out, although they're a very helpful feature within the React Router library, but we don't use them in the Movies app. And again, it's all about, it kind of goes back to having meaningful URLs within your overall app design. And I can, arguably that's kind of meaningful. That's telling. When I look at that URL, it's I can work out, well, obviously I'm displaying something from a user's inbox, which user, this user here, and as well as maybe some general inbox related, maybe their list of current emails or whatever. I also want to include some statistics about that user on the actual page. Whereas down here, I want to list all of the draft emails that the user has created. I want those to be somehow displayed or referenced on the web page that shows more general information about the user's inbox content. That's sample 4, I think. Yeah, sample 4. And really, this is the key component. The rest is as before. But is it worthwhile just, I won't look through the code, but I will just show it working. So back to my base index, change it to sample 4. Check that we're on the home page. It's not essential that we're on the home page, but it just saves me having to type in localhost all over again. So again, just for illustration purposes, I've got this hyperlink here, and when we look at the browser's URL, if I click on this hyperlink, I'm changing it to just /inbox/ the inbox ID. And so what's rendered here is coming straight from the inbox component. Whereas when I click on this hyperlink, I now have the /statistics bit at the end, and I have what the inbox component renders, and this is what my stats component renders. Again, nothing too interesting, but it's proof that the stats component is mounted in addition to the inbox component, whereas it wasn't in the previous example, in the previous hyperlink. And the third hyperlink tags on the draft at the end of the URL. And this stuff here is coming from my, sorry, I clicked on the wrong one, this one. This is coming from my draft component. Probably worthwhile just glancing at the some of the code. Again, just for convenience, I've stuffed a couple of components into one file. Here's the inbox that we've seen. And here's the, okay, I'm using a message component, that's okay. And here's my stats component, and here's my drafts component. And yeah, they're not actually that interesting. I am actually passing some props. Am I passing props down to them? Stats params, use params. Well, okay, I'm using the params, the use params hook within my stats component, so they can access the, it can access this variable here within the path. Similarly, for the drafts component, it's accessing this variable within the path. So it's making use of that use params hook. And at the index.js level, this is the top level routing entry that takes us to the inbox section in the first place. Here. Now, again, this kind of addressability, what's nice about the fact that React supports addressability is if I take this URL, and let's forget about security now and all of that stuff. If I take this URL and let's assuming this little application is mounted on some cloud service, it's not running on localhost. If I pass this full URL to you and you enter it into a browser, then you will get all of this directly. You don't have to go to the home page and kind of navigate to this particular view within the overall app. So that's nested routes, a really nice feature of the React Router library, which I don't use, I know, in the movies lab, but maybe I should try and stitch it in just to have a real life illustration of it. Back to the link component. So far, when we use the link component, we just, as a prop, we pass a URL in the to prop. And we know what happens when the user clicks on the hyperlink, routing configuration kicks in, and some component is mounted onto the DOM as a result of that hyperlink being clicked. But what if we want to pass some props to that component that's mounted? And the only place that we know what the prop values are is wherever the link is contained. So how do we pass props to the mounted component as a result of clicking on a hyperlink? And this is where the extended form of the link component will allow us to do that. So the objective here, as I said, is to pass additional props via a link. And the illustration is in sample 5, but here's the key part of it. Now, it's a made up example. And when I reflected on this before the lecture, I was thinking it's probably not a good illustration of it, but let's just go with it. So the idea is that here, this hyperlink here is implemented with link, but here's how I've actually implemented the link. My to prop now is not taking a string, it's actually taking an object. The double curly braces is important here now because the outer curly brace is just honoring the fact that we have to wrap any variables mixed into our JSX, we have to wrap them in curly braces so that they get evaluated. The second curly brace is just the beginning of my object that I want to have passed as the to prop. So this object, it has a path name key in it, and that contains the actual URL path that we want the browser to change to. So that's the same as before. The state property within this object, that's where we put these additional props that we want to have passed to the mounted component. Now it's makey-uppy stuff, right? So I've got two key value pairs. So these are the two additional props that I want to have passed to my mounted component. Why I say this is a bad example is I've actually included the user ID as a prop. I prefer the user ID to be part of the URL really rather than a prop, but let's just ignore that for now. So these are two props that I want to have available to my mounted component. This is still my routing entry that will deal with the fact that when the browser's URL changes to this, so it's going to mount the inbox component. So it's inside in the inbox component. How do we get at these two additional props? And again, the React Router library provides us with a nice, convenient hook for doing that. I'm not sure where they came up with the name, but it's called the use location hook. And here we are using the hook. So we just, sorry, where do we use it? Up here, sorry, yeah. Use location, doesn't take any arguments. What the use location hook, essentially what it returns is this, this object here on the right. So what I'm doing here is I'm performing destructuring, but I'm actually performing destructuring on a nested object. This variable here, location, I forgot the end, it should be location really, I should have called it, but location is an object with one key in it. The key is state, and the value associated with that key is this value here. So what I'm destructuring here is I'm saying take the state key within location and then destructure the object associated with that key. So the kind of the net effect is two local variables called user and beta are created, and those two variables are going to be assigned what I've assigned, the corresponding keys over here. So this destructuring is quite sophisticated, I suppose, if you like, in that we're destructuring a nested object. This is the actual object that we're destructuring, the nested object within this outer object here. This outer object only has one key in it. The key is state. If it had other keys, that wouldn't matter. In fact, it may. I didn't look at the detail of it, but you can see when you do when the console.log of it, as far as I know, it only contains one key called state. It may have others, but we are actually only interested in the state key. And then we destructure the object associated with that key. And here I'm confirming it in terms of what I'm outputting onto the screen. So sample 5. Sample 5. Let's look at it in action first. Okay, so here I'm kind of proving to E that I'm picking up the additional props here. But that doesn't really prove it, I suppose. I should look at the code. Let's look at the code for the inbox in sample 5. Although I've just shown you the code on the slides, but here it is here. And if I leave that open and I look at the hyperlink itself, sorry, no. Sample 5. Oh yeah, I've put everything into the same one file again. So here's the routing configuration at the top level, nothing new there. Here's the hyperlink that I clicked on, passed in 2 key value pairs, user, having the values user ID. Where did the user ID come from? I've just hard coded it here. And I've assigned beta this meaningless string called something else. And then if I look at the inbox component itself, it's outputting, let's see, where did that come from? Oh yeah, it's outputting, I'm doing my destructuring and I'm just outputting beta and user. And so that's where these are coming from. That's where these are coming from. So my inbox component is getting at the additional props that were passed via the hyperlink. And we'll see that in use in the Movies app later on. That's the extended link idea. an example of it. Now, apps tend to have a common overall look and feel to them. And by that, I mean, and this is kind of standard practice really, for any kind of browser-based app, not just React now, but there tends to be some sort of navigation links at the top. And these navigation links are constant across all pages in my app. In other words, there's kind of a header, which may contain, usually does contain navigation links, but it's a standard header anyway, and that's consistent across all of my pages. Similarly, there may be a standard footer that's consistent across all pages. There may be a side menu as well that's standard. And the only part that tends to change as you navigate from page to page or from view to view is whatever is being rendered in this kind of section of the browser screen. So this is dynamic, whereas this stuff here is static. This is static, and maybe there's a static part over here as well. So the question is, how do we achieve these static parts across all of our pages? And it's actually pretty straightforward. So in the case, in the sample, I have a number of pages. And again, I'm sticking with my inbox little use case. So my home page, it has this standard header on top with some navigation links to some of the other pages. There's a standard footer as well down here. And as we go from page to page, we'll see that every other page has the standard header and the footer. How do we implement that? It actually goes back to your routing configuration. So within your routing configuration, you can have your own custom components. So the header component and the footer component, and you can call them anything you want to, but they're meaningful names. Those two components now are actually going to be rendered for every one of my route entries, for every one of my pages. And it's as simple as that, really. Now, in the sample, my header is implemented using the Bootstrap CSS library rather than Material UI. But so there's no real need to look at the detail of header and footer. In the lab, we will implement a header and footer using Material UI. So it's this idea anyway of you can actually mix in your own custom components into the routing configuration, and they have the effect of including those components, whatever they render, including them in every page across your app. React Router library refers to them as persistent elements or persistent components. So sample 6, I won't look at the detail of the code now, but I'm sure you get the idea of what we're trying to achieve. So if we change it to sample 6, so here's my home page, and as I navigate around, they remain constant. Okay, we'll see that in, I think it's next week's lab, we bring in that into our movies app. Time-wise now, where are we? Okay, alternative route. Let's just cover this one, then we're finished. So the route entry in our routing configuration, the limitation with it at the moment is we cannot pass props to the component that we want to have mounted as a result of the React router making a routing decision. So component X in this case. Is there any way we can pass props to that component and express that in our routing configuration? And the answer is yes, but we have to use a slightly alternative form of the root component. And the alternative form looks like this. So whereas up here, the props are path and component, in the alternative form, it still takes the path prop, but the second prop is called render. And the render prop, you can pass it a function. And you can have any logic in that function that you want to. Typically, the logic would be concerned with setting up these additional props that you want to have passed to the component. But the return statement of the function, it will return the component that you want to have mounted. But in that return statement, you can actually add the props that you want to have passed to the component. So in our sample 7, what's sample 7 doing? We're passing. Okay, so again, we're kind of sticking with this inbox use case. And earlier on there, we had a stats component, but it was completely static. Pardon the pun. Let's supposing we want to pass as props into our stats component some statistical information related to the particular user's inbox, like how many emails do they send on average, how many emails do they receive on average, whatever the nature of the props are. But we want to pass that data in as props to our stats component. That's our objective. Now, it happens to be that our stats component, the routing entry associated with it is a nested root. That's just coincidental. We can use this alternative form of the root component up at the top level routing configuration if we want to. So this is the way we had it before, okay, which is no use to us. This is how we would rewrite it. So here's our nested root entry, and here's the render prop that we're passing. And we are actually encoding here in using the arrow style, we're encoding a function. The function returns the component that we want to have mounted. Now, as I said, normally you might have some logic in here computing the props. I have just hard coded them, but that'll do. So this is my statistical data that I've wrapped as an array, and I'm passing it down to my stats prop, and I've called the prop usage. The other stuff over here, it's a bit tricky, but really all that's happening here is, you see the root component itself, it will receive props. And we want to pass those props down to the stats component. In many cases, your custom component here, it is not really interested in any of the props that were made available to the root component, but in some cases it may be. So really all I'm doing here is I'm taking the props and I'm destructuring them, because props is an object. I'm destructuring it. In other words, I'm kind of spreading it out as key value pairs, and they are being passed down to my stats component should it need to use them. We tend to do that as just boilerplate, even though in many cases it won't actually need to access these props at all. But it's kind of a default feature that we use with this alternative root entry. You see, the root component, it's actually going to invoke this function, and it's passing to the function an argument. You can call that argument anything you want to, but what the argument actually is the props object that was passed to root itself. So it's simply passing it down into the function, and the function is using it in this way here. That's a pattern as well, if you like to use that term, pattern. That's a pattern at the kind of micro level. That's a coding pattern that we see used whenever we use this alternative form of the root, root component. That's a bit tricky, I know now that necessarily, but you can just regard it as boilerplate really for now. I think I'm just expressing that there. And this is the stats component, and there's nothing interesting going on inside there other than it's obviously accessing this usage prop that's being passed down into it. I think that's all it's doing. Okay, that's sample, whatever it is, sample 7. You can look at that yourselves. I think that's it. So there are, if I look back at the code sample, we're up to sample 7. There are sample 8 and sample 9. There's 2 other samples that we need to look at. We look at sample 8 next week, and we'll actually look at sample 9, I think, the following week. Right. So a lot of talk there. I'm going to leave it at that for today. I'm not sure if there's any closing questions from you. There usually isn't, but that's okay. Let me just share my screen again. I won't share it, sorry. Right. You're still there anyway, which is good. Are there any questions, I wonder? By the way, I will have the spec for the first assignment next week, and I'll talk through it with you next week. So you've got that to quote unquote look forward to. All right. That's it, folks. And I will touch base with you on Thursday. Thanks for now.
Thank you.
Thank you.